Namaste. Welcome to our new channel, Dr.ARM's Chemistry. Friends, in order to avoid confusion due to similarity in names of this Chemistry Made Easy channel, there are still few more chemistry channels of the same name. So we have decided to change this name, and the search can be made very easy for you. So I hope that you will be convenient with this change and you will cooperate. So please take that this channel Chemistry Made Easy, which was existing earlier, is now converted into another channel name, that is Dr.ARM's Chemistry. So again, welcome in this channel, and we will see today this topic, theories of acids and bases. And by this time we have discussed a variety of theories under this topic. And today we are going to see this point, quantitative measures of acid-base reactions. So by this time we have seen theoretical approach to this hard and soft acids and bases, and now we are going to see some quantitative approach. So some terms which were discussed here, which are discussed here, are in quantitative or are of quantitative nature. So Pearson in 1988 proposed his concept of hardness having the terms such as hardness. So hardness is given as eta, which is the difference between ionization energies and electron affinity values, and half of that difference. So eta, that is hardness, is half of the difference of ionization energy and electron affinity. So this is the first term given by Pearson in 1988. So according to this, here ionization energy is the energy of highest occupied molecular orbitals, and it is given as minus I. And this electron affinity A is energy of LUMO, that is lowest unoccupied molecular orbitals, and it has negative sign. So you will observe in this diagram that we have taken here the Levy's bases, F minus, Cl minus, Br minus, and I minus. So here you will find that this is the LUMO having value just above minus 18. Means in this diagram we are saying that is above. So here the HOMO has values on this axis like this, and LUMO has values on this axis just above minus 4. So we have taken here 0 electron affinity, and all these values are carrying negative sign. And according to the definition of hardness, that is eta, it is the half of that difference between the LUMO and HOMO. So it is the half. So we can take either this half or this half. Means it is the same. And here X is electronegativity. So electronegativity is another term given by this Pearson. So this is also the difference, means half of this ionization energy and electron affinity. So it is taken as just a half of that sum of ionization energy and electron affinity values. So if we consider the hardness of F minus, you will find that the hardness is much more compared to the hardness of other species. So compared to Cl minus, Br minus, I minus, the hardness, that is eta value, is much higher than that of Cl minus, Br minus, and I minus. So as we go on moving from F minus to I minus, the eta values are found to be decreasing. Means hardness of this species is decreasing from F minus to I minus. And IF minus has highest value of hardness. So this is just for comparison of the hardness. Similarly, we can have the electronegativity, that is X. So here X is having negative value because it is just the half of the sum of electron affinity values. It is the sum of that electron, this I minus I and A, that is ionization energy and electron affinity, that is sum of these values and half of that. So this is carrying negative sign, but this is not carrying any negative sign because it is just the difference between two values. But I minus is negative, A is also negative, but we are not concerned here with the sign of these I and A. We are taking just the difference of I and A, and that is why the values of eta that is are not carrying any sign. So this is just the half of the difference, and X, it is the sum of I and A upon, but I is negative, A is negative, and therefore sum is negative and half of the sum is also negative. So it has minus value. So similarly in case of OH minus, so this is about Al3 plus and this is about OH minus. So eta value for OH minus is 5.67, but X is the minus 7.5. So this is because of the negative values and half of that values. So in this way we can have the variety of species and for which we can find out the specific values of these hardness and electronegativity, so which are helpful for us to consider various other applications. So we will stop our discussion here and we will discuss the next point in the next lecture. So till then, goodbye, see you next time. So please subscribe to this channel and press bell icon and like button. So thank you very much for watching this video.